السلام عليكم ورحمة الله وبركاته. بسم الله الرحمن الرحيم. Dear students, today inshallah we're going to talk about one of connective tissue in which the matrix is hard. Today's lecture is about the bone. By definition, the bone is modified type of a connective tissue in which the matrix is solid. As we said before, the connective tissue is formed of cells, fibers, and matrix. Here, the matrix is solid due to deposition of calcium. What is the function, or what are the functions of the bone? Formation of adult skeleton, protect vital and important organs as the skull protect the brain. The thoracic cage protects the lung and the heart. Act as a reservoir for minerals, mainly the calcium. What are the characters of bone? We said it's formed of cells, fibers, and matrix. These cells are widely separated, so the intercellular substance or the matrix is abundant. The bone is highly vascular, arises from undifferentiated mesenchymal cells, UMCs, from the mesoderm. It is hard due to deposition of minerals, mainly the calcium and the phosphorus. The bone is covered from outside by the periosteum and lined from inside by the endosteum. Again, the bone is formed of cells, fibers, and matrix. These cells, we have four types of cells: osteogenic, osteoblast, osteocyte, and osteoclast. The fibers, we have collagen fiber type 1. And we said that the bone matrix is hard due to deposition of calcium. The bone matrix is formed of organic component, which is known as osteoid, inorganic component, and water. The organic component constitute 35%. It's formed of fibers, which is collagen fiber type 1. And this about 90% of the organic portion. And it is responsible for the acidophilia of the bone when stained with hematoxylin and eosin. Again, in the ground component, there is ground substance which is formed of protoglycan and glycoprotein. The organic component is secreted by the bone cell before being mineralized. The bone cell secrete the collagen fibers and the ground substance, then after their secretion it will be mineralized. What the meaning of mineralized? Deposition of calcium. The inorganic component, which is 65%, is formed of calcium, phosphate, and carbonate. They are present on the surface of the collagen bundles and within the ground substance and cause hardness of the bone. The bone matrix is arranged in the form of lamellae. Lamellae means layer of calcified collagen bundles embedded in calcified ground substance. Here is the bone lamellae. Here is the bone lamellae. What the meaning of osteoporosis? It's a common disease caused by increased bone resorption, what the meaning of resorption. You're going to understand it well when we study the osteoclast. Bone resorption is over the bone formation. The cell responsible for the bone formation is known as the osteoblast, and the one responsible for resorption is known as osteoclast. So when the osteoclast work more than the osteoblast, there will be progressive loss of the bone density, and there will be increased risk for bone fracture. Again, you said that the bone is formed of cells, fibers, and matrix. What are the cells which present in the bone? You said that they are 4 types of cells. The osteogenic cell. Here is a diagram showing 3 cells only. The osteogenic cell is present at the periosteum and endosteum, and here there is no periosteum or endosteum in this diagram. The osteogenic cell is the progenitor cell or the mother cell. Osteoblast, which is the bone forming cell. The bone forming cell will secrete the bone. And the osteocyte, which is the mature bone cell. And the osteoclast, which is the bone-eating cell. Again, we have 4 types of cells. Osteogenic, which is the mother. Osteoblast, the bone-forming. Osteocyte, mature bone-maintaining cell. And the osteoclast is bone-eating cell. For 1 second, ask yourself why I want to eat the bone. This occurs during growth of the bone and during healing of fracture. The osteogenic or the progenitor cell. Osteoblast is the bone-forming cell. Osteocyte is a mature bone cell. And osteoclast is the bone-eating cell. First, we're going to study the osteogenic or the progenitor cell. It arises from the UMC and the periosteum. As you can see here, this is a diagram. You can see that the cell is flat cell with flat nuclei. Where could I see it? In the inner layer of the periosteum and in the endosteum. We said before that the bone is covered from outside by periosteum and lined from inside by endosteum. Where could I find the osteogenic cell? In the inner layer of the periosteum and in the endosteum. They are flat cell with flat nuclei, and the cytoplasm is pale basophilic, so I'm not very active cell. Pale basophilic. I'm having few organelles, mainly the ribosomes and the centrioles, which give me a great hint why they're mainly ribosomes and there is centriole, because this cell is mitotically active cell. What the meaning of mitotically? Undergo a process known as mitosis. So this is the mother cell. What is the function of this mother cell? They can divide and give rise to osteoblasts. They are well developed during growth and in fracture. If this osteogenic has a poor blood supply, it could be changed into chondroblast, not osteoblast. Normally, the osteogenic give osteoblast. If poor blood supply in an area of poor vasculature, this osteogenic cell changed into chondroblast instead of osteoblast. Osteoblast is the bone-forming cell. The bone-forming cell. Look, dear students, 2 diagrams. This one, this is a tissue. This is the matrix of the bone. Here, the osteoblast on the surface, and this is osteoclast, and this is osteocyte. The osteoblast arises from the osteogenic cell. So they are present near their mother, inner periosteum and endosteum. These cells are active, arranged on the bone surface like epithelium on the bone surface. Okay? This diagram shows what? That it is highly active, basophilic cytoplasm, negative Golgi apparatus, pale nucleus with prominent nucleoli. This is active protein producing cell. Again, here, dear students, the osteoblast. The osteoblast present on the surface. They are oval cell, having processes. The nucleus is rounded and eccentric with negative Golgi apparatus and negative Golgi image and has alkaline phosphatase enzyme. By EM, I am protein producing cell. RER, Golgi apparatus, ribosomes, mitochondria, and secretory vesicles. These secretory vesicles contain the alkaline phosphatase enzyme. What's the function of the osteoblast? Synthesis of the organic components of the matrix, which is type 1 collagen and the matrix. The newly formed organic material before being calcified is called osteoid. Then the osteoblast will secrete alkaline phosphatase. This alkaline phosphatase will attract calcium from the blood to the matrix in order to do what? To calcify the matrix. When the osteoblast become imprisoned in a calcified matrix, it changes its name into osteocyte. 10 to 20% of the osteoblast differentiate into osteocyte and the majority undergo apoptosis, programmed cell death. Okay, dear students, this is a diagram showing what? These are bone lamellae and there is a lacuna. Inside the lacuna there is osteocyte. Again, the osteocyte is what? Is mature osteoblast. Osteoblast, after secreting the matrix and become calcified, after adding alkaline phosphatase, that will precipitate the calcium from the circulation to the bone matrix. It will be imprisoned in a lacuna and change its name into osteocyte. Present singly inside the bone lacuna. Present single in the bone lacuna in between the bone lamellae or the layers. They are communicated together. This is a cell and this is a cell and this is the processes. They are connected together. These processes present in these canaliculi. Again, this is an EM picture. This is the osteocyte and these are the processes. The osteocyte present inside lacuna and this is the bone. The osteocyte present inside lacuna and the process is present in the canaliculi. Another photo. These are the osteocytes. This is the lacuna and this is the canaliculi. The osteocyte less active than the osteoblast, so they are smaller. Oval, branched cell. The cytoplasm is less basophilic. By EM, present inside a lacuna, connected together through the canaliculi. Okay, the process is connected together through the canaliculi by gap junction. Why gap junction? To allow passage of nutrition from one cell to another cell. This is scanning electron microscope. This is the bone matrix, this is the lacuna, and this is the osteocyte, and these are the processes. By EM, I'm less active, so I'm having less RER Golgi apparatus than the osteoblast. The function I'm going to maintain the matrix. So I'm going to form collagen and the organic component, and I'm going to harden the matrix by deposition of the calcium. Same function of the osteoblast, but less active. The one who did the job is the osteoblast. The osteocyte will just maintain. Only one osteocyte present inside the lacuna, so this cell cannot divide. When we compare this cell with that of the chondrocyte. We said that the chondrocyte inside the lichen can divide inside the capsule to form cell nest. Here in the bone, no. The lichen contain only one cell and cannot divide. Okay, dear students, here is the mother cell, give rise to the osteoblast. When the osteoblast secrete the bone matrix and become calcified, it changes into osteocyte. The osteocyte has processes. The processes communicate with the neighboring cells through gap junction. This is the osteocyte, basophilic, present inside the lichen, and this is the processes present inside the canaliculi. Osteoclast. Look, dear students, two photos. The cell is large cell. Why it is large and why it contains many nuclei? Because it's formed of fusion of many cells. Multinucleated giant cell fusion of many hemopotential progenetic cell in the bone marrow. Fusion of many cells present in the bone marrow. Present on the bony surface where it we're going to resorb it. I want to resorb this bone, so the osteoclast present on this surface. When it resorbs this part, you can see an empty area here, which is known as Hauschup's lacuna. It's a depression near the bone marrow cavity produced by the erosion action of the osteoclast. Hauschup's lacuna. Again, by light microscope, it is a very large cell with foamy acidophilic cytoplasm. I can see from 6 to 12 nucleus. The cell surface facing the bone, I can see here ruffled surface or brush border. Finger-like projection. This ruffled border or brush border is the finger-like projection where facing the part that I'm going to do resorption for it. The cytoplasm contains many mitochondria, lysosome, Golgi apparatus, vacuoles, and ribosomes. The function is bone eating, responsible for remodeling during growth, okay, and in healing after fracture. You're going to understand well remodeling in the second lecture when I'm going to talk about ossification. The osteoclast has a great mission to do. I want to remove calcified or digest calcified matrix. Okay? In order to remove the calcium, I want acidic media. Why? When I want to precipitate the calcium, I had alkaline phosphatase. I want to get away the calcium, so I want an acidic media. How I'm going to have this acidic media? Inside the osteoclast, I'm having enzyme known as carbonic anhydrase. When water combines with oxygen, it forms carbonic acid that dissociates rapidly into bicarb and hydrogen. This hydrogen will be present in the matrix, acidifying the matrix, removing the calcium from the bone and through it to the blood. The lysosomes containing acid phosphatase and proteolytic enzymes will be released from the osteoclast and will lead to digestion of the organic material. Bone resorption. Again, this is the osteoclast, and this is the ruffled border, and here is the part that erosion takes place. Carbon dioxide plus water form carbonic acid that dissociate rapidly into hydrogen and bicarb. The hydrogen released in the matrix to acidify the matrix. Acidifying the matrix, I'm going to release calcium. I'm going to move this calcium from the bone and go to the blood circulation. I'm going to take the calcium that's present in the bone and I'm going to throw it in the circulation. The osteoclast contains exocytotic vesicle. What the meaning of exocytotic vesicle? A vesicle inside the osteoclast containing lysosomal enzyme, release this lysosomal enzyme to the Hauschips lacuna in order to do digestion. Then the digested part will enter again the cell through endocytic vesicle, and this vesicle is known as endocytotic vesicle. Contains what? Contains the degraded bone product. It will be present inside the cell. Then it will be discharged by exocytosis from the basolateral aspect of the osteoclast. Again, exocytotic vesicle containing lysosomal enzyme that will be released at the Hauschips lacuna in order to digest the organic component. After digesting the organic component, I'm going to do endocytosis, and I will let this degraded part to enter inside the cell. And this is endocytotic vesicle. This endocytotic vesicle will discharge the content by exocytosis at the basolateral aspect of the osteoclast to the circulation again. Again, dear students, this is the osteoblast. Will form the bone. When become embedded in a calcified matrix, it will change into osteocyte. And here are the processes, and here are the junction between the processes. On the surface in which I want to do resorption, I'm having large multinucleated giant cell, which is the osteoclast with the ruffled border. Again, osteoblast, osteoclast, and this is osteocytes. Here is a table to differentiate between two cells. First, why I want to differentiate between them. Both are large cell and the nucleus is, here is multi-lobed nucleus and here is a multinucleated. These cells are megakaryocyte, which is the mother cell of the platelets, and the osteoclast. The megakaryocyte is present inside the bone marrow, while the osteoclast present in the Hauschips lacuna. The diameter of the megakaryocyte is from 50 to 70 micrometer, while the osteoclast is about 150, about the average, the double of the megakaryocyte. The cytoplasm of the mega is basophilic, here is foamy acidophilic. The nucleus is single but multi-lobed, entered in interphase, okay, duplication of the DNA and do not divide. So the nucleus is multi-lobed. While here it is multinucleated due to fusion of many cells together. The megakaryocyte important for platelet formation, while the osteoclast is important for bone resorption. What is the periosteum and endosteum? All bone except at the joint surface is covered at the external and the internal surface with the vascular connective tissue. The periosteum, by its name peri around, it is a vascular non-calcified connective tissue sheath formed of outer fibrous layer, which is formed of dense collagen, which is collagen type 1, rich in blood supply. This blood supply penetrates to the inside of the bone to supply the bone. An inner osteogenic cell. Dear students, you heard osteogenic cell before? Yes, it's the mother cell that produces the osteoblast. The inner osteogenic is formed of closely arranged osteogenic cells. Okay, that will form the osteoblast. What is the function of the periosteum? Here is the periosteum, outer fibrous layer and inner osteogenic layer. First, nutrition, as it contains blood supply. Second, muscle attachment, the tendon attached to the periosteum. Repair of fracture. Why? You said, yes, here, dear students, that the periosteum is formed of outer fibrous layer and inner osteogen. This osteogenic change into osteoblast, and the osteoblast form bone. So it's important in repairing of the fracture. If fracture occur, I'm going to form new bone. And it's important for appositional growth. Appositional growth. I told you before, dear students, about the appositional growth in the cartilage before. And we said that appositional growth of the cartilage occur by the inner chondrogenic. Okay, if this is the bone, and I made a cut section like this, okay, here is the cut section. From outside, I'm having the periosteum, which is formed of outer fibrous layer and inner osteogenic layer. This inner osteogenic layer, when this inner osteogenic produce osteoblast, it will build here bone from outside, okay, increasing the diameter of the bone. So that's called appositional growth. The endosteum, it lines the inner surface of the bone. It's formed of single layer of osteogenic cell with loose connective tissue. It supplies the osteogenic cell and the osteoblast. Yes, again, it's important for growth of the bone and important for healing of fracture. Anatomical classification of the bone. We have long bones as the bones of the limb, short bones as the bones of the hands and the feet, flat bones as that of the scapula, ribs, skull, irregular bone as that of the vertebrae. Histological classification. We have two types of bones. The compact bone or the regular bone, as you can see here, this is the compact. Cancellous or irregular or spongy bone, from its name as a sponge. First, we're going to study the compact bone. It is highly organized, hard, dense connective tissue. As we said, it's in the bones of the limbs that we're going to carry your body weight. So it should be highly organized and hard, dense, present at the shaft of the long bones, and covering, this is very important, covering the plates over the surface of spongy bone. One of the example of a spongy bone is the that surrounds the brain. Okay, so this spongy bone is going to be protected by a plate of compact bone. First, I want to know the meaning of bone lamellae. It is a thin plate of the bone formed of calcified collagen bundles. Between the lamellae, there is the lacuna containing the osteocytes. Again. Here is concentric bone lamellae, and here are lacuna that contains osteocyte. And this is something called Haversian canal. I'm going to tell you what is Haversian canal after 1 second. Here is the shaft of a long bone. I cut a section and I see here this compact bone, this wedge of compact bone. Again, okay, from outside I'm having the periosteum, and from inside we're having the endosteum. The periosteum is the outer cover of the bone and is formed of outer fibrous layer and inner osteogenic layer. Then we have something known as outer circumferential lamellae. Haversian system, interstitial lamellae, inner circumferential lamellae, and endosteum. Again, I want to have a well-organized hard tissue. The building unit here, something called the Haversian system. As you can see here, the Haversian system is cylindrical in shape. If you put many cylindrical structures near each other, space will be present. This space will be present between the Haversian system and the periosteum, Haversian system and endosteum, and Haversian system between them. Between the Haversian system, there's going to be space. Okay, I'm going to fill this space. The outer circumferential lamellae by its name, outer, near the periosteum, in which the bone lamellae here are parallel to the periosteum, and here are the lacuna containing the osteocyte. Outer circumferential lamellae. The inner circumferential lamellae, okay, they are parallel to the endosteum, the bone lamellae parallel to the endosteum. Interstitial lamellae, the space between the Haversian system, in which irregular bone lamellae containing the osteocyte inside the lacuna. Again, here is a wedge, okay, if I'm having, this is the bone, I cut it TS, so it appears like this, round structure with you. I took a wedge, okay, this is the periosteum, and this is the endosteum, and these are the Haversian system, and this is the Haversian system. The Haversian system is longitudinal, okay, parallelly arranged, present on the long axis of the bone. Okay, I'm going to have one Haversian outside. I'm going to study it. I can see here a canal containing blood vessel. This is Haversian canal. And these are concentric bone lamellae. Between the concentric bone lamellae, I'm having osteocyte. Inside the osteocyte, I'm having lacuna. And these are the canaliculi. If, as I said before, I put many cylindrical structures near each other, spaces will be present. The space between the Haversian and the periosteum are going to be occupied by the outer circumferential lamellae. The space between the Haversian and the endosteum are going to be occupied by inner circumferential lamellae. Between the Haversian, I'm having interstitial bone lamellae. Dear students, what is this? This is that one and that one, Haversian canal. What is this? It's another canal known as the Volkmann's canal, connecting Haversian with Haversian, Haversian with periosteum, Haversian with endosteum. Why? I want the bone to be highly vascular tissue. These canals, okay, we're going to make the blood supply inside the bone high blood supply. Okay, I'm going to transmit nutrition. Again, what is the Haversian system or osteon? And take care, osteon, not osteoid. Osteoid is the organic component. Osteon, Haversian system. The Haversian system is formed of Haversian canal, parallel to the long axis of the bone, containing blood supply, blood vessel, surrounded with concentric. What the meaning of concentric? Like this, concentric bone lamellae. In between the bone lamellae, I'm having lacuna containing the osteocyte. Again, dear students, what is this? It's the Volkmann's canal. What is the Volkmann canal? It is a communicating transverse canal linking Haversian system with each other and havirgin with periosteum, havirgin with endosteum. Okay, again, here is a TS section and here is an LS section. Here is the havirgin canal and this is the Volkmann canal. How to prepare a section of the bone? We have two methods. First, is it easy to prepare bone? No, it's difficult. Why? Because it is hard. So I want to take away the calcium by a process known as decalcification. We said in order to calcify, I put an alkali. In order to remove the calcium, I put an acid. I'm going to take the bone and put it in a nitric acid to dissolve the calcium, to change to soft tissue. So I can see the periosteum, endosteum, and the organic. Here is a diagram for decalcified compact bone. From outside is the periosteum, inside there is the endosteum. Here are the havirgin system, havirgin canal, concentric bone lamellae, osteocyte in between. Here is the outer circumferential lamellae, inner circumferential lamellae, and these are the interstitial bone lamellae. Another technique is the ground bone section. The bone allowed to dry, and I'm going to use something called carborundum wheel. I'm going to cut it very small and thin transparent section, and I'm going to put it on a slide without stain. These cells were going to die, and air will replace spaces. What are the spaces? The lacuna, canaliculi, and the canals, havirgin and Volkmann. And the bone matrix appears as papyrus paper. Okay, unstained piece of the bone. Okay, no living tissues. I can see the lacuna, havirgin canal, Volkmann canal. This defined here is the canaliculi. Again, here is the ground compact bone. This is havirgin canal. This is havirgin canal. This is Volkmann canal. Okay, here are the lacuna, and these are the canaliculi. Lacuna. Okay, here is the havirgin canal, and there is the Volkmann's canal. What is the perforating fibers of Schurbe? They are calcified collagen fibers, which is present in the tendons or the ligaments at the site of muscle attachment. This calcified collagen will perforate the periosteum to be attached on the outer lamellae to become continuous with the collagen of the matrix of the bone, to fix the tendon to the bone. Again, here is the bone and here is the periosteum. Here is the tendon of the muscle. Okay, it's going to perforate the periosteum and we're going to be present here, attached here to the matrix of the bone, become calcified and attached to the matrix of the bone. How the bone repair? When there is fracture, the bone repair is faster than the cartilage because the bone is highly vascular. At the site of fracture, blood clot will be formed. Degranulation of the platelets degranulate and release cytokines that produce inflammatory response and start of healing of the bone occur. Here is the fracture, hematoma, degranulation of the platelets and inflammatory process start, and then I'm going to pass with steps, then I'm going to have healing of the fractured bone. The second type of the bone is the spongy or the cancellous bone. It is an irregular type of a bone. The first bone during fetal life and occurs during bone repair. Present in the center. The word center is very important. Center of epiphysis, flat bone, and irregular bone. Why I said center? Because at the periphery of this bone, the compact bone will be present to protect it, will be present to protect this spongy bone. Again, here is the cancellous bone, irregular bone trabeculae, and these cavities are the bone marrow cavities. There is a compact bone to protect this spongy bone. It is formed of branching and anastomosing irregular bone trabeculae. Inside the trabeculae, there is osteocyte present inside the lacuna. Between the trabeculae, bone marrow cavities present. Inside this bone marrow, inside these cavities, the bone marrow is present. There is no Haversian system. The bone surface is covered with periosteum and lined by endosteum. The bone marrow cavities lined by endosteum. Okay, this is irregular bone trabeculae containing osteocyte inside lacuna. Between the trabeculae, there is multiple bone marrow cavities. From outside, I'm having the compact bone, then the periosteum, and the endosteum, having many endosteum lining the bone marrow cavities. Again, this is bone trabeculae. This is osteocyte inside the lacuna, and here are the cavities, which is bone marrow cavities. Thank you, dear students. Second lecture, inshallah, will be the ossification.